We've been talking about Riemann sums, and you can do it with left and right rectangles and all of that kind of thing. Here's an equation. It's sine of 2x. It's this equation up here. And right now, it says that n equals 8. So that just means there's 8 rectangles that's drawn for us. It looks like that we're using the right endpoints. It doesn't matter. I could do upper or lower sum, whichever makes more sense. But we'll just leave it at right for now. Let's just see what happens if I move n equals 8 to a larger number of rectangles, which physically it's hard to do that exactly. So, you know, it looks like that the more rectangles I draw, the better the area is going to be. Notice if I continue drawing and drawing and drawing, it looks like here that the area is really, really close to being what the area is. So basically what we want to happen here is that we want to find the limit of these rectangles. We want to find the areas of those rectangles and find the limit of them. And that leads us to today's topic, which has to do with a definite integral. So in finding the limit of the rectangles, that's what these symbols here, it says the limit of the change in x. So basically the change in the rectangles, we want the change to be 0 because we want the rectangle's width to get smaller and smaller and smaller. We want n to be large because we want a larger number of rectangles. This is saying of f of x and then times the change in x, which is the width. So we're saying that that limit is equal to this new notation, which is an integral. We talked about an integral before. We found the antiderivative, but the way that we notate it is from a to b. A is called the lower limit, b is called the upper limit, and that is like from where to where. Like if we were finding rectangles from 0 to 3, a and b would be 0 and 3. So this is our new notation, and this represents finding the area from a to b of f of x. And it's from the curve to the x-axis, and there is a little bit of issue that we need to talk about whenever it's below the x-axis, but you're always going from the curve to the x-axis. So here's some pictures, and what I want to do is I want to write the symbol for finding the area of these three pieces. And the shaded part, the yellow part, is the part I'm trying to find the area of. So for number 1, we would just say the integral from, it looks like we start here and go to here, 0 to 5 of f of x and then dx. Dx sort of represents our change in x, and it's really small, so we put that in there. Alright, for number 2, looks like we're going from here to here, so the area is negative 2 to 2 of f of x dx. Number 3, looks like we're going from here to here, so it would be the integral from 0 to 3 of f of x. And we're just letting all of those functions be f of x. In some of the problems you'll see you might have equations there, and you would just put them in the place of f of x. Alright, something else that we can do is we can find areas geometrically. And here I went ahead and put pictures in there just so that the pictures will help you make sense of it. But if I want to find the integral from 1 to 3 of 4 dx, well, first of all I have to draw 4, which is this line here. And then I have to go from 1 to 3, so I know it starts here and goes here. Well, if it's a rectangle, I know how to find that area. I know that the width here is 2. I know the height here is 4. So my area is 8. And some of these you'll just have to draw the pictures yourself. I just went ahead and put pictures just to make it easier. So the next one, it says the integral from 0 to 3 of x plus 2. Well, this line is x plus 2, so we want to find this area. Well, normally what I do when I have a trapezoid is I just separate it. I normally find the area of the rectangle, and then I would add that to the area of the triangle. If you would rather do trapezoid, that is fine. I just think it's easier to do it that way. The bottom area is going to be 3 times 2 because it's over 3 and up 2. The top area is 1/2 times the base, which would be 3, times the height, which is from 2 to 5, so it's also 3. So we have 6 plus 9 over 2, which is 10.5. All right, and number 6, we want to find this area. This one's kind of tricky just because it's a semicircle, but I just wanted to talk to you about it. Just make sure you draw it on paper, and then you go from -2 to 2. So this is half of a circle. We know that the area of a circle is pi r squared, so we're just going to then multiply by half or divide by 2. So we just need the radius of the circle. The radius would be this part of it from 0 to 2. So our radius must be 2. So that's 4 multiplied by a half pi, and we get 2 pi for the area. So if it says to find it geometrically, they just want you to use what you know about areas to find those. Now there's some properties about integrals that you need to know. And so I wanted to show you that here. First of all, the first one, if you have the same number to the same number, that's kind of like finding the area from that number to that number. Well, there's no area because it's just a line. And so this is equal to 0. Anytime the numbers are the same, that integral would be 0. The next one says find the integral from 0 to 4. Well, we've just talked about how we do that. Looks like it's a half times the base, which is 4 because we're going from 0 to 4, times the height, which looks like it's 1. So that should be 2. C says find the integral from -4 to 0. Well, if I find that area, it's also 2. It's 1/2 times 4 times 1. But anytime that the area that you're looking for is below the x-axis, then we multiply by a -1, or we just make it a -2. So if the area is above the x-axis, the answer is positive. If the piece is below the x-axis, I find the area, but then I put a negative on it, because negative is below the x-axis, positive is above. D, if I want to find the integral from -4 to 4, well, what that means is that I can take the integral from -4 to 0 and add the integral from 0 to 4, so the integral would be 0. So integral is a little different from area just because negative can happen with integrals and positive is above the x-axis. So basically what D says is that if you find the integral from one part to another part, you can just add those parts together. E is the integral from 4 to 0. It kind of looks the same as B, except it's 4 to 0, it's backwards. Well, if it's backwards, you find the integral from the normal way, like smallest to biggest, like 0 to 4, like B, you get 2. And then you change the sign. If that would happen to have been negative, then you would change the sign to positive. For example, if it gave you C, if it said 0 to -4, instead of -4 to 0, if it said it the opposite way, then the answer would have been 2 instead of -2. So you just change the sign if the order is not smallest to largest. Okay, here's another one. Lots of questions. And on this problem, I've given you the areas. I've told you that from -2 to 0, the area is 3. From 0 to 2, the area is 1. And from 2 to 7, the area is 5. So if I'm going to do integrals here, I'm going to do the integral from -2 to 0. So -2 to 0 is just this area right here. So that would be just 3. Next it says the integral from 0 to 2. So there's 0, there's 2. This is below the x-axis, so it's not just 2. Because it's below, it's -2. Next says integral from 2 to 7. So here's 2, here's 7. It's just this part right here. We know the area is 5, so this is 5. D says the integral from -2 to 7. And so I just take all these pieces and add them together. So it would be 3 plus -2 plus 5, which would be 6. E says the integral from 2 to 7. We already have that one. I'm not sure what that was really supposed to be, but we'll just go ahead and put 5 there because we know what that is already. F says the integral from 2 to 2, for the integral from 2 to 2. That's no area because the things are the same. And then last says integral from 7 to 0. It's backwards. So the integral from 0 to 7 would be -1 plus 5, which is 4. So the integral from 7 to 0 would be -4. We'll do some more with these properties later.